In this lecture, we are going to learn what is lexical environment for an execution context and how the scope chain gets created using that lexical environment. So in the last lecture, we learned what is a scope and what are the different types of scope we have in JavaScript. And we also talked about lexical scoping. So basically we learned that whatever variables and functions we create in the global scope, that means the variables and functions which is not present inside any function or code block, that is present in the global scope, and that can be accessed from anywhere in our JavaScript code. Now, we also learned that every function create its own scope, and whatever variable and function we declare inside that function will have a scope of that function. And since a function, in this example, this calculate age function, it is sitting lexically within the global scope, this calculate age function will have access to all the variables and functions declared in the global scope. Then inside this calculate age function, we are also creating this isFullAge function. So this isFullAge function will create its own scope. It will create a function scope, right? And since this isFullAge function is sitting lexically within the calculate age function scope, it will have access to all the variables and functions declared in the scope of calculate age function. In this example, it will have access to birth year variable, current year variable, age variable, as well as this message to variable. Because this message to variable is created using var keyword, so this message to variable will have a scope of this calculate age function, because this message to variable is being declared inside this calculate age function. Even though it is present inside a code block, since it is created using var keyword, it will have function scope. It will have the scope for the function inside which it is declared. And in this example, this message to variable is declared inside this calculate age function. So it will have scope of this calculate age function. And since it has scope for this calculate age function, we learned that since this isFullAge function is sitting lexically within this calculate age function, it will have access to all the variables and functions which has scope of this calculate age function. And this message to has scope of this calculate age function. So this will also be accessible inside this isFullAge function. And then this if code block will also create its own scope. And whatever variable and function we declare inside this code block, if it is created using let or const keyword, it will have block scope. But if it is created using var keyword, then it will have function scope. Okay, so here we are also creating a block scope. And since this scope is sitting lexically within the scope of this calculate age function, it will also have access to all the variables and functions which is declared inside this calculate age function. And it will also have access to all the global variables and functions. So this is what we learned in our last lecture. And here, this is called as lexical scoping. A function or a code block sitting lexically within another scope will automatically have access to all the variables and functions which is declared in its parent scope and their parent scope. So this isFullAge will have access to all the variables and functions of this calculate age function. And since this calculate age function is sitting lexically within this global scope, this isFullAge function will also have access to all the variables and functions declared in the global scope. All right. So now we know what is lexical scoping. But how does this lexical scoping gets created during the creation phase of the execution context? That's what we are going to understand in this lecture. So to create the scope chain for an execution context, we use something called as lexical environment. Now, lexical environment is like a structure that holds identifier variable mapping. Here, identifier refers to the name of the variable or the function, and variable is basically the reference to the actual object. And this we will understand with an example. Also, during the creation phase, a lexical environment gets created for the scope of the current function. In the creation phase, lexical environment is identical to variable object. And a new scope gets created for each lexical environment, but only when the code in that lexical environment is executed. The lexical environment also has a reference to its outer lexical environment. So let's try to understand these statements with a simple example. So here we have a very simple JavaScript program. So it is basically the same program which we saw in our last lecture. Now, when this program will be executed by the JavaScript engine, first of all, for all the global variables and functions, a global execution context will be created, because we have learned that all the global variables and functions gets stored and executed in the global execution context. And during the creation phase of the global execution context, first of all, its variable object will be created, which will store all the information like the parameters, the variables, and functions declared in the global execution context. So for the global execution context, since we don't have any parameters, that's why this arguments is, it is an empty object with a length as 0. And in here, we also have two variables, which is declared in the global scope. And during the creation phase, since these variables are created using let keyword, they will be assigned with uninitialized. And in the global execution context here, we will also have this calculate age function, which will point to the definition of that function. So that is not here, that is not written here, but this calculate age function will also be here as a property of this variable object, which will point to the definition of that function. And after the variable object is created for this global execution context, its scope chain will be determined. And after that, the value of this variable will be determined. Now, in order to determine the scope chain, the execution context uses something called as lexical environment. All right. And in this lexical environment, we will have two properties. The first property will be the environment record, which will point to this variable object, the variable object of this execution context. And that's why I mentioned that during the creation phase, the lexical environment will be identical to variable object, because in the lexical environment also, we will have access to all these variables and parameters which we have for that particular execution context. So since this environment record is pointing to this variable object, inside this lexical environment, we will have access to first name variable, last name variable, and this calculate age function. And also if we have any parameters, we will have access to those parameters as well. All right. Then in this lexical environment, we will have one more property called outer. And this outer property will point to the lexical environment of its parent scope. Now, for the global scope, we don't have any parent scope, right? Global scope is the outermost scope. So we don't have any parent for the global scope. And that's why you will see that in this case, this outer is set to null, because it is not pointing to any outer scope. It does not have any parent. Okay. So after this global execution context is created and executed, then we are calling this calculate age function. Now, when the calculate age function will be called, an execution context for that calculate age function will be created. And during the creation phase of this calculate age function, again, its variable object will be created, which will store all the parameters, its values, and the variables and functions declared inside that. And after the variable object is created, the lexical environment for that execution context will also get created. So in this case, a lexical environment for this calculate age function will also get created. And as we learned in the lexical environment, first of all, we will have environment record, which will point to the variable object of that execution context. So this environment record here, it is pointing to the variable object of this calculate age execution context. That means inside this lexical environment also, we will have access to all the variables, parameters, and functions which is declared inside that function using this pointer. Then this outer property of this lexical environment will point to its parent scope. In this case, for this calculate age execution context, its parent scope will be the global scope, right? So here, this outer is pointing to the lexical environment of the global execution context. So we saw that in the lexical environment of global execution context, we have a pointer to the variable object of this global execution context. And that's why inside this lexical environment, we will have access to the variable object of this calculate age function, as well as to the variable object of global execution context. Okay. Then after this calculate age function is executed, from within that calculate age function, we are also calling this isFull age function. So when this isFullAge function will be called, an execution context for that isFullAge function will be created. And during the creation phase of this isFullAge function, again, the variable object for that isFullAge function will be created. And after that, the lexical environment of that isFullAge function will be created. And in that lexical environment also, first of all, we will have the environment record, which will point to the variable object of that execution context. And then we will have this outer property, which will point to the lexical environment of global execution context and the lexical environment of calculate age function. Now, here you might have a question. So, if this isFullAge function has access to the lexical environment of global execution context as well as the lexical environment of calculate age function, then in that case, if I go back, you will see that the lexical environment of this calculate age function is pointing to the variable object of this calculate age function. And there we also have message1 and message2 variables stored, because this message1 and message2 variable, it is present inside this if block. So we have learned that since this message1 variable is created using let keyword, it will have block scope. It can only be accessed inside this if block. But message2 is created using var keyword, so it will have function scope. So if we have access to this lexical environment of this calculate age function within this isFullAge function, in that case, this isFullAge function should also have access to this message1 variable, right? But that should not be the case, because these two are creating two different scopes and they're not sitting lexically within each other. So this isFullAge should not have access to this message1. But whatever we have learned so far, on the basis of that, you can say that in that case, the lexical environment of this isFullAge function should also have access to this message1 variable. Well, that is not the case. Why? Because even though in the lexical environment of this isFullAge function, we have access to calculate age lexical environment, and in the lexical environment of calculate age function, we have access to message1 variable, the scope chain will be created only during the execution phase. Okay, the lexical environment will be created during the creation phase, but using this lexical environment, a scope chain will be created, and that will be created during the execution phase. And there, when the scope chain will be created, in that scope chain, this message1 will not be present in the scope chain of calculate age function, and that we will see in a bit. Why I'm explaining this lexical environment is because the scope chain gets created using this lexical environment. So you should know when this lexical environment gets created and what does it store. Now, once the lexical environment is created, based on that lexical environment, the scope chain will be created during the execution of that execution context. All right. Okay, so this isFullAge function, the lexical environment of this isFullAge function is first pointing to its variable object. That means inside this lexical environment, we will have access to all the variables and parameters and functions which is present in this variable object, as well as we will have access to all the variables and functions and parameters present in the lexical environment of global scope and lexical environment of calculate age function. So this is how the lexical environment for each of these functions will be created when they are called. Now, during the execution phase, using this lexical environment, JavaScript engine will create a scope chain. So let's learn how that scope chain will be created. So first of all, a scope chain is a hierarchical structure that JavaScript uses to search for variables and functions. It is essentially a linked list of accessible scopes from the most immediate context to the global execution context. And the scope chain for a function is created during the execution phase. So here it should be execution phase. Okay, so when the execution phase of that function's execution context will start, that time only the scope chain will be created. Okay, and this happens just before the function is actually executed. Now, how this scope chain is created? So each function has its own lexical environment, which contains an environment record, That means a reference to the variable object of that execution context, and it also stores a reference to its outer lexical environment. We saw that with examples. So the outer reference in the lexical environment, it points to the parent scope's lexical environment. We have just seen that, right? And when a function is executed, its lexical environment becomes the starting point of the scope chain. The outer reference in this environment points to the next scope in the chain, and so on until the global scope is reached. So let's see how the scope chain will be created for the example which we just saw. So again, first of all, for the global code, the code which is present inside the global scope, for that a global scope will be created, and that global scope will store all the variables and functions declared in the global scope. In this example, it is going to store the first name and last name variable as well as calculate age function, because these are declared in the global scope. Then when the calculate age function will be called, for that a scope for this calculate age function will be created, and it will store all the variables and functions which has the scope of the calculate age function. In this example, the birth year, current year, and age has a scope of calculate age function because it is declared inside that function. And this isFullAge function also has a scope of calculate age function because this isFullAge function is also declared inside the calculate age function. And then this message to variable, since it is created using var keyword, we have learned that a variable declared using var keyword will always have function scope. So this message to variable will also be present in the scope of that calculate age function, as you can see here, but not the message one variable. Message one variable has block scope. Okay, so it will be present in the scope of that if block. So after the scope of this calculate age function will be created, it will also have access to its parent scope. In this example, the global scope. Okay, so inside the scope of this calculate age function, we will have access to all the variables and functions declared in that scope, as well as the variables and functions declared in its parent scope. In this example, in this global scope. Then, in this example, a new scope will be created for this if block also. So when that scope will be created, that scope will store all the variables and functions declared in that scope in that code block using let or const keyword. In this if block, there is only one variable which is declared using let keyword, which is this message one. So this message one will be present in the scope of this if block, as you can see. Okay, so it should be message one and not message two. All right. Message 2 is created using var keyword, so it will have function scope. So in this if block, message 1 variable will be present, and since this if block is sitting lexically within this calculate age function, it will also have access to the scope of that calculate age function. And since this calculate age function also has access to this global scope, indirectly this if block scope will also have access to all the variables and functions declared in the global scope. Then this isFullAge function is also going to create its own scope, and in that scope we will have all the variables and functions declared inside that function. In this example, there is only one variable which is declared inside this isFullAge function, so that will be present in that scope. Okay, and since this isFullAge scope is sitting lexically within the scope of this calculate age function, this scope will also have access to its parent scope. That means it will have access to all the variables and functions present in its parent scope. And since its parent scope has access to global scope, inside this isFullAge scope will also have access to all the variables and functions declared in the global scope. All right, so this is how the scope chain gets created. And the scope chain gets created using the lexical environment. During the creation phase, in the lexical environment of this calculate age function, we will also have message one variable. But when the scope chain will be created, at that time, this message one will not come in the scope of calculate age because this message one has block scope. So it will be present in the scope of that if block. So in the lexical environment, we had this message one variable, but during the execution phase, when the scope chain will be created using that lexical environment, JavaScript engine is smart enough to understand in which scope this message one variable should be created and in which scope this message two variable should be created. Okay, so here this if block will have access to all the variables and functions declared in its parent scope and their parent scope. In the same way, this isFullAge function will have access to all the variables declared in its scope, its parent scope, and their parent scope. But this if block and this isFullAge function, they will not have access to variables and functions declared within their scope. So this if block will not have access to this isEligible function, and this isFullAge will not have access to this message one variable. So again, this should be message one and not message two. All right. And one more thing which you need to remember here is that the scope chain always goes in upward direction. So the child scope will have access to all the variables and functions of its parent scope and their parent scope. But vice versa is not true. That means a parent scope will not have access to the variables and functions declared in its child scope. This is very important to understand. So I hope now you understand how a scope chain gets created for a given scope using the lexical environment of an execution context. So here lexical environment is very important because the lexical environment is the one which creates the scope chain. And it is also important to understand that a lexical environment gets created for an execution context, for a function. The JavaScript engine does not create different lexical environments for different scopes. For example, inside this calculate age function, we are creating two scopes. First scope will be for this calculate age function, and the second scope will also get created using this if block. So when the lexical environment will be created for this calculate age function, we are only going to have one lexical environment that will be for this calculate age function. We are not going to have two separate lexical environments, one for calculate age function and other for this if block. Okay, we are only going to have one lexical environment which will store all the variables and functions declared in that function. So in this example, the lexical environment of this calculate age function is going to store all these variables. This is full age function, and it is also going to store this message one and message two variable, even though this message one variable is created in a different scope, in the scope of this if block. Still, it will be stored in the lexical environment of calculate age function. But during the execution phase, using that lexical environment, JavaScript engine will create scope chain, and it is smart enough to understand which variable should be present in which scope. I hope this point is clear. So this is how the scope chain is determined for an execution context. Now, before we wrap up this lecture, I also want to mention one more thing, and that is the order in which the functions are called and executed in the call stack. It does not determine the scope chain. The order in which the function is executed and the scope chain are two different things. They are not related in any way. Let's try to understand this with an example. So here we have a very simple JavaScript program. So when this program will be executed by the JavaScript engine, first of all, it will create a global execution context where all the global variables and functions will be stored and executed. In this example, this variable x, this first function, and this third function will be stored in this global execution context, and there they will be executed. Then we are calling this first function. So an execution context for that first function will be created, and it will store the variables and functions declared in that first function. And from within this first function, we are also calling this second function. So an execution context for that second function will be created, which will store all the variables and functions declared in this second function. Now, once the execution of this second function is complete, its execution context will be removed from the call stack. And then from within the first function, we are also calling this third function. So an execution context for that third function will be created in the execution context where it will be executed. Now here, since we are calling this third function from within this first function, this does not mean that this third function will have access to all the variables and functions declared in this first function. That is not true. The order in which the functions are executed does not determine the scope chain for that program. Okay, here first function is calling third function. That does not mean that third function will have access to all the variables and functions declared in this first function. Let's try to understand it. So for the global execution context, when the scope chain will be created, it will store all the variables and functions declared in the global scope. So it will store this variable x, it will store the first function and third function, right? And it will also have this outer, which will point to null, because for the global scope, there is no outer lexical environment. Then when the first function will be called, at that time, a scope for that first function will be created. And this first function is going to store the variables and functions declared inside that first function. In this example, it is going to store this variable y and this second function. And it is also going to have a pointer to its parent scope. In this example, to this global scope. So inside this first function, we will have access to all the variables and functions declared in the first scope, as well as all the variables and functions declared in the global scope. Then when the second function will be called, again, a scope for that second function will be created, and there we will have the variables and functions declared in that second function. In this second function, we are only declaring one variable called z. So that is present in that scope, and we don't have any other variable or function. So in that scope, in the scope of second function, we have access to variable z, as well as it also has access to its parent scope. In this case, to this scope of this first function, right? Now, from within this first function, we are also calling this third function. So a scope for that third function will be created. And in that third function, we are storing this variable n. So that is there in that scope. And then inside this, we don't have any other variable or function. So the scope of this third function is going to store that variable n. And it is also going to store a reference to its parent scope. And what is the parent scope for this third function? It is the global scope. So it is going to store a reference to that global scope. So as you see, even though the first function is the one which called this third function, the scope of third function does not have access to the scope of first function. So this is very important to understand, that the order in which the execution context for a function is created and executed does not determine the scope chain. All right, so this is all I wanted to cover in this lecture. I know the concepts which we have covered in this lecture might be a little bit confusing or a little bit difficult to grasp, but whatever we have learned in this lecture will help us understand many more concepts in this JavaScript course. For example, we are also going to talk about closures in JavaScript. And the closure concept in JavaScript, it highly depends on this scope chain concept. So if you have not understood the concepts which we have covered in this lecture, I will highly recommend you to go through this lecture 2-3 times so that everything becomes more clear. This is all from this lecture. If you have any questions, then feel free to ask it. Thank you for listening and have a great day.